textbook. Today we're going to be going through the model and discuss, as well as examples 1 and 2.
Piecewise defined functions will be our focus, and we promise they're easier than you think.
I can graph and interpret piecewise defined functions is our learning target. As you watch this video, you can kind of be thinking, how do you model a situation in which a function behaves differently over different parts of its domain?
Okay. A music teacher needs to buy guitar strings for a class. At one store, the guitar string costs $6. At this other store, it's $20 for a pack of 4. So what we need to do is use the pen tool and make graphs that show the income each store receives if the teacher needs 1 or all the way through 20 guitar strings. So they give you a little graphing space. You can number it out how you want and maybe use different colors for the different stores. Describe the shape of the graph. And again, these don't have necessarily like a right answer or a way to check yourself. So go ahead. Do you want to?
Oh no, I was just saying that I was just thinking in my head that we're activating some prior knowledge, and so as we think about it, if I was thinking about the 6 each, I'm thinking that that's a pretty straight line, a very linear situation. When I think about this $20 for a pack of 4, if I only needed 1, I'd still have to pay $20 at that store. And so I'm thinking about labeling this bottom, and I'm thinking about this being the number of guitar strings, and I'm thinking about this being how much it costs. And so 1, 2, 3, and 4 would all be, if I said $10 and $20, no matter what. This whole time it would be $20. Then if I needed 5, I would have to jump all the way up to $40, right? So this is kind of a confusing kind of start there, but I'm kind of thinking it through and thinking about the situation because it happens a lot in life.
And this right here is all there is to piecewise functions. It's just defined in pieces. Different x values have different chunks. So we would say, well, from 0 to 4, and now you're familiar with what domain is and how we write that. So from 0 to 4, the y value is defined one way. From 4 on to 8, it's defined another way, from 8 to 12. So I think people get intimidated by the words piecewise defined, but it just means you're defining it different pieces.
And it wants you to compare these graphs. So there is, when you type in here, you're not going to see anything. However, you can kind of really relate it to a lot of things that you've done in the past.
We'll come back to this, and I don't think it's a bad idea to make a good guess at this and then do a couple of the examples and maybe you return to it and be like, oh, now I know, like if you didn't realize originally that this would be in these horizontal chunks, maybe after you do a couple things, you'll see that more too. Okay, so this person has a job as a lifeguard. This is example 1. Oops, I just scooched it too far. Example 1, and we do want you to be filling out your workbook. So remember, you're clicking through all the parts of this, taking notes. And then this is example 1 on page 10 now. And we'll have you submit some pictures of the pages, or we'll physically collect them or stamp them. So we do want you to be filling out the paper copies. Anyway, this girl has a summer job as a lifeguard. She makes $8 an hour up to 40 hours each week. If she works more than 40 hours, she works 1.5 times her hourly pay. And I don't know if you know about jobs much, but that's realistic. When people get time and a half for working overtime.
Or hazard pay, or
yeah,
different circumstances change their pay.
So 8 times 1.5 is where they're getting the $12 from for each hour over that. So for the first 40 hours, it's just a straight line, $8 times how many hours she works. But then when she gets to this one point, the slope of that graph is going to switch. So different pieces of the x-axis have different behaviors. How could you make a graph and write a function? So again, I just did it, but kind of thinking before you hit solution, thinking through it, making a prediction.
Just as Mrs. Conway said, we can kind of see, and they selected 20 first to give them a point down here. Each one of these has a value. Their table just chose to start at 20, go to 25, 30, 35, and 40. And so that's the orange section of our graph. When she gets down here, that rate has changed, and so you can see the green line is a little bit steeper. So step one was make a table. You should do that by hand and write it out somewhere in order to make the graph. Step two, notice that the plot contains two linear segments with a slope that changes slightly at x equals 40. So that's our spot where things change. This is the definition of a piecewise function. All right, so we need to write an equation. And this might be the intimidating part, but don't let it intimidate you. Just kind of think of it in chunks.
So the first part, write an equation for each piece of the graph. So when x is greater than 40, we know that she's getting $12 per hour. So this is one explanation, and it's fine. They're talking about your starting value, because you're going to be starting up at 160, where the other graph left off. I would have probably started with this bottom part. So she's working $8 per hour. So you're thinking about that graph again, $8 per hour until we get to here, right? So we need to first come up with an equation for that part of the graph. 8 times how many hours she works. So you could think of this as the y equals 8x, right? Now for this one, we need to know where does this start for the other part of the equation. And so we know that the slope for the second part is 1.5. It's going to be 1.5 x plus something. And so that's finding that starting number is what they're doing here. So 12x, oh, it's not 1.5x, it's $12. This one was $8, this is 1.5 times that. So 12x, she's gonna go $12 up, $12, $12 every time she works an extra hour. But finding this y-intercept is what I think is tricky. And so there's a lot of different ways to do it depending on what algebra experience you have.
But let's go through this conclusion because that'll be the one that we want them to reference.
Okay. So this is just a pretty way to write it. We can talk in a second about how to get to that negative 160 again. But the 8x on this part of the graph is like kind of step one. From 0 to 40, she gets $8 per hour. When she gets over 40, she gets $12 per hour, but she doesn't have to start back at 0. She starts wherever the other one left off. So how did you do that for finding this? Do you have an easy way?
Nope.
Okay, so this is my thought, is that at 8 hours, it was at 40 hours, it was 8 times 40, so she was at $320 at that point. So the way I like to do this, and I think your Math 1 teachers might have taught you, was so you have this equation for the other part. We know a point, this is a point on the graph, 40 goes with 320, right? And then y equals mx plus b, we know the m is 12. We know our x value, we're just gonna borrow that point for just a minute to solve for b. This is how I would do it. There's other ways. The x value I have here was 40 plus b is what I need to solve for, and it equals 320. So 12 times 40, what's that? 440. Is it? 12 times 4 is 48. 480 equals 320, and I gotta do plus b, minus 480 from both, and I get b equal to negative 160. And so if you remember, this is some Algebra 1 stuff, which would be Math 1, Math 2 for you. When you're writing an equation of a line, you don't know where it crosses the x-axis, because remember, this is like imaginary over here. We don't have a line over there. We just have this chunk of it. So we need to know what would have been the y-intercept if that line had continued. Now remember, that line doesn't continue because we've limited the domain there. But
The way that the text is suggesting is they say, okay, you can slide in that 40. So you can make a compound equation. And so they're putting that in and then saying that x minus 40, because when you get here, you're taking your x values away from 40, away 40. I think this way is a little bit easier, but in either case, when you write this as a piecewise function, you're going to have your first equation here that goes from 0 to 40, so this first piece of the graph, and then you use a second equation, but we did have to have that negative 160 or minus 160 there, otherwise that wouldn't be a true equation right there. So using this graph, we can figure out her pay over time.
Yep. And I think that 160 might have been the confusing part, but the rest of this hopefully isn't too terrible.
I think we've got bullets at the top.
Okay, page 1, page 2.
Mm-hmm.
So here's your try it. She makes $8 for up to 40 a week. If she makes more than 40 hours, she makes 1.5. So same situation. How much will she earn if she works 37 hours?
And so since this is a try it, we won't finish it out for you, but you have to decide based on the interval that we saw in the previous screen. So if it's 37, then we're going to use this first piece. If in part B, it's 43, I think, and so we're going to use the second equation. Make sure to check your work and to give it a star.
For that one, I like to do it two different ways too. I kind of like to do the equation because I just came up with it. I love it. I think it's good. But then I also, in real life, like I might just say, like for the 43 hours one, I might just be like, well, for the first 40 hours, like I might just make a little chart. For 40 hours, try it with my equation, get my answer, and then also say, okay, for the first 40 hours, I know she's made $320. And then she has $3 more at $12 an hour. So maybe adding on that 36 and see if that total matches what you got from your equation.
That's why we love math, because we can check our work and we can solve it in multiple ways, and one not being better than the other, but getting us to that same result, and then considering which is the most efficient in each situation. All right, we are on to example 2.
Should we just do 2 in this video?
Yeah.
Otherwise they get too long.
So again, don't let this notation scare you away. We're saying that f of x is 3 different pieces, and these are going to be our intervals.
One thing I do sometimes, if this is overwhelming, just do one chunk at a time. Maybe even just get a sticky note. Get your grid out, cover up everything except leave open -10 to 2 on the x-axis, and graph this line just like you know how. And then cover up everything from -2 to 2, and graph this parabola just like you know how. And then eventually take those off, and the 3 go together. Oh, kind of like those funny things where it's like an elephant head and a giraffe body. You know?
Yeah,
Remember
I
those?
do. I like those.
I do too. We should bring some.
Yep, I have some.
Oh, I knew you would.
So we're literally thinking about what are the domain and the range. And so as we start, we're going to sketch the first piece. Notice how this graph doesn't continue right here. Notice how this is a closed circle down here. And so this is our first piece. Like as Mrs. Conway was saying, like your sticky notes would be here and here because this is our first piece. Then we're going to sketch that second piece. Just a little smiley face of a parabola. And our final piece, cruising toward the end of our interval.
The color coding just makes me so happy.
I don't know if you can see it on the video, but you can definitely see it in your Canvas course or on Savas, whichever.
I really think the domain you can kind of gather from this. It's probably going to be -10 to 10, but really don't even answer these until you've graphed it. Because once you've graphed it, it's pretty easy to see.
Definitely.
It goes from here up to here. It goes from here over to here. And so I think the graph is the best way. And now these can be done on Desmos. We may have another little video about that. You can do these pieces on Desmos if you want. But it's just a little tricky notation as well.
So we have our minimum at negative 29, that'd be this red point right here, and our maximum y value is going to be this green point, which happens to be 11. Notice how they substituted in the x value, the highest x value, into that last equation in order to get that 11.
And they plugged it into the appropriate little section of where it fit into that domain.
Yeah. So the range is negative 29 to 11.
And the domain is the negative 10 to 10. And they're going to demonstrate for you that set builder notation once again, where it's just a good old inequality. X such that negative 10, that x is between negative 10 and 10. Y such that y is between negative 29 and 11. And they're going to ask about increasing, decreasing to just bring you back to section 1.1, which I appreciate. And again, looking at the graph is really a nice way to do that. Uphill, 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 so it's increasing for these x values, decreasing for this little piece because it's going downhill, uphill again, and uphill again. So just take time and don't just skip right over that, because we've done it with some predictable functions, and these are just a little less predictable.
Well, and there's a lot of words, so making sure that you're taking time to compare them to the graph and understand what